Now members, let us see motion under gravity. Now this one happens when, say, push a body upwards. So see, if I have this chalk, when I pull it up there, it starts moving in a linear motion, but it's acted upon the gravitational force. So when I throw it upwards like this, you see that there's something that pulls it down, and in science we call that the gravitational force. So now, you know gravity is pulling something down. So when it pulls it down, where the gravity is positive, the acceleration that is pushing it down is positive. But when it's moving up, we say it's always opposing gravity. So that's why we say that the acceleration, when it goes up like this, is going to be negative. So that's the reason here. The three equations can be modified for motion under gravity. Gravitational force pulls the body downwards, so as it's G. So it's G. And if the body moves upwards, then the gravity is negative G. So downwards, because it's acting downwards, it's positive. So the acceleration that is driving that body is going to be G, because it's the rod that is driving the body to go downwards. But when it's moving up, it's now the acceleration will be opposing the gravity. And so whenever there's an opposition on the anything, then we give a negative sign. So using these three equations of motion, in upward now, when we have an upward motion, there is now acceleration is going to be negative G, because it's opposing gravity. Gravity pulls down, so it's pulling it down. So when it's coming, but when it's going up, it means that it's opposing gravity. That's why the expression here is negative G. So here, where it is A, we are putting negative E from these three equations. That's what we have. Now downward motion under gravity, downward means it's now going by the gravity once it's just coming down. So now it means that the acceleration is going to be G. Now the gravity always is accelerating that body to go down. And so there will be, the way I say we put G as simple as that. The difference here, this one is moving up, that's why we have a negative G there. K3, particle released from rest. When the particle is released from rest, so when we have, here we are assuming that it's falling down from maybe a table, then it falls down. So it's that the gravity is going to be positive. That solution is positive because it's falling down. There's no any position. So these are the equations we have. So if you want the final velocity, you can get the square root, you can get it there. If you want the distance, very obvious. So here our U is 0. That's why we have those things like that. Now the understanding is coming in here. When the body is thrown upward, if it reaches, this one is if it reaches the maximum height. Now, the moment I throw, let me do some illustration here. When I throw this chalk like this, it's going to reach a certain point, then it falls down. But now there's that height it reaches before it comes back. Now that height it reaches is what we call the maximum height. Look at this chalk. It's going to reach a certain height, then it falls again. So, I think we've seen a certain height, then it falls again. Now, this height here is what we call the maximum distance or the maximum height. It reaches somewhere, then it falls. I think it's somewhere, then it falls. Now, before it falls there, it's that now there is a moment there when it's coming there. Now there the final velocity is 0 because it's not moving. Because if it was moving, it would have been going up. But when it is there, that moment before it comes down, there the velocity is 0. Because if it's not 0, it would have been moving. Hope you get it. When it reaches that height, before it falls, the velocity there is 0 because it's not moving. So that's why at maximum height, always the velocity is 0. Now if we put 0 in our equation, because we are throwing it up there, so meaning we are opposing the gravity, so we are using these ones there. So when we put our V at 0, this is what we get. Now this T, we have got this T at maximum height. Maximum height, the final velocity is 0. Now, to get this T, it means that now this T is the time for our body to reach its maximum height. As simple as that from here. Okay, from this equation now, when it's 0, now we want to know what is that distance, or how can we get that maximum height. So the maximum height happens when this, remember the maximum height is the distance we are looking for, s. So if you make s the surrogate, now this is the maximum height, which we call s. You know, s means distance, and distance now we are going to mean height. So at this point here, our time is t, u over this given by initial velocity over the gravitational force. This one is given by initial velocity squared over twice the gravitational force. Now, whenever they ask you to get the maximum height, always just use this formula, because at maximum height, this is how we have generated them. When s is 0 after upwards projection, then we substitute here. Now, when s is 0, it means what? The distance now it is covering, when it comes to 0, it means that now it has reached the point where it started. You know, when I reach this chalk, when I throw this chalk upwards, it's going to cover some distance. But when it falls into this hand, then the distance is going to be 0. So look at this, then it falls in here. So me now it has come back to where it started from. There we say the distance covered now is 0. When does that happen? Whenever that happens, it means that now the time it used to go up and then to come down is going to be the same. That's why when it's here, it's t equal to ub. But when it's coming down, this time plus this time, we have as 2 is twice the time it used to go up. Hope you get that. Okay, so now, after that now, this t equal to 0 means that here, it has, when we put our 0, remember we don't divide, we factorize out the common thing which is t there, and I factorize this 3 will be 0. When I equate now this, all this will be 0. This 2 will multiply this and divide this by b, that's what will be. And now this t is when the body is just, at this point, be 538. That's what this t means, be 538. So that is t equal to 0. But when it comes, then it falls into the sun. There, this is the t we are talking about. It has come, the time it has used to come, go up, come back, is the time we are talking about there. So this is the time when the body returns to the point of projection. So at this point of projection, so s is 0. So it has covered this distance, then it has, so it means in simple terms, up then coming back. So in simple terms, the distance has been cancelling itself because of a negative, and then the positive. That's why it's coming to 0. And so at that time, the time for this to come back to the original position, that's it there. Now we are going to see examples in the next lesson, but these are very important things to note because we are going to apply them there as we are going to see. See you there.